Hello there, Kaim here. Tonight I'm holding my 21st birthday party and I'm bringing 4 of my closest friends tonight. Can't wait. But hold on a minute. I forgot about my 1-week relationship anniversary. Cries. But wait, I think I have a great idea. Hear me out. So here's our game plan. Let's do a scavenger hunt. It'll surely take down 2 birds with 1 stone and it's gonna be an epic party. How do we apply graph theory to all this?
Before we move on to the story, let me tell you what graph theory is all about. Well, first of all, graph theory is the study of graphs, which are mathematical structures used to define relationships between objects. For example, graph theory can be used to find the shortest distance between 2 places. In our scenario, we are trying to help the girlfriend finish the scavenger hunt using the shortest route through graph theory. Now, let me introduce you to some of the key terms in graph theory and how it relates to our scenario. First of all, we have the vertices, which in graph theory are the objects that we are interested in. In our scenario, it's the places to visit in the scavenger hunt. We use red circles to represent the vertices. Then, the edges are the relationships between objects. In the scavenger hunt, it is possible path taken by the participants. Last but not least, we have the weights, which are represented by numbers with values and units. This will be labeled on our graph to represent the distance from one vertex to another. You will see how it will be applied later.
How do we apply graph theory in our scavenger hunt? So firstly, she would need to plot each point, and for this case, the red dot represents the location that all contestants need to go to win this scavenger hunt. The lines represent the edges which are connected to all the vertices, and the distance calculated is the shortest distance to reach from, for example, the patio to the living room. So the calculations, we've done it in Paint, and by just having 2 points, like we click 2 points, we can get the x and y axis of 2 points. And by using Pythagoras theorem to find the hypotenuse, and after converting this into cm, we will find the distance from gym to terrace, for example, right now.
So the patio is our starting point. But in order to find the distance from the patio to the gym, we use the pixels on our map and we substitute. We can see here 5, 8, 6 and 1, 1, 3. This is the distance in pixels from the patio to the gym. What we're going to do is we're going to substitute this into the right angle triangle formula to find the hypotenuse, the formula being c equals square root a square plus b square. Substituting 586 and 113 into this formula will give us 596.8, which is still in pixels. From then on, we're going to have to convert it from pixels into cm. We use an online converter, but the fixed conversion is 1 cm equals 38 pixels. For the gym, we do the same process. We substitute it into the formula for Pythagoras theorem and we convert it. We get 9.8 from the gym to the laundry and so on. So we repeat this process for the laundry, living, terrace. Now we're going to talk about complete graphs. So what is a complete graph? A complete graph is any graph. Each vertex has an edge to all other vertices. That is called a complete graph. This is our complete graph that we have made. We can see the 5 red dots, which are our settings for the scavenger hunt. The living room, the patio, terrace, gym and laundry. And we can see the edges, which are all paired to the vertices. And each edge carries a weight. These are the distances between the vertices. So which is the best way to win the scavenger hunt? The most optimal path to win the scavenger hunt is we start from the patio, then we're going to travel to the terrace. This is a distance of 12.1 cm. Then from the terrace, we are going to the gym, which is 5.5 cm. From the gym to the laundry, 9.8 cm. From the laundry to the living room, 4.6 cm. So thus we have ended the scavenger hunt, but there is a catch. We have to take pictures of all of these areas, then return back to the starting point. That's a requirement to end the scavenger hunt. So we are going to go back to the page show 13.3, and in doing so we've completed a circuit. A circuit is following from one vertices and it ends back at the same vertex. It's a cycle because it doesn't repeat any vertices and each vertex only repeated once.
Given a set of nodes and relationships, which can be confusing in anything from city layouts to computer data, applying graph theory can help quantify and simplify the many moving parts of dynamic systems. Studying graphs through a framework provides answers to many arrangements, networking, optimization, matching, and operational problems. Thus, graph theory is applicable in our case study, as our case study contains a lot of points, also known as nodes, and relationships. There are many advantages for using graph theory to decipher the best route for the scavenger hunt. One of them is that graph theory can connect many points or nodes together to form various possible routes for the scavenger hunt. By forming the connection between all the points or nodes using graph theory, one can find out the exact number of possible routes from the connection of points. In conclusion, graph theory enables us to study and model networks and solve some difficult problems inherently capable of being modeled using networks. Various terms like vertex and edges are associated with graph theory, which gives these terms special meanings. These meanings need to be understood and remembered in order to apply graph theoretic approaches to solving problems.